All right, so today our objective is that we are going to solve and graph one-step inequalities. So before we go ahead and do that, if you haven't already, before I jump to that, if you haven't already, go ahead and make sure you print your guided practice or your guided notes if you haven't already. And if you cannot, that's also okay. Just make sure you have some paper and a pencil to go ahead and take notes as we go. So if you printed the guided notes, you can go ahead and put this activation of prior knowledge at the top. And if you're taking notes, you can go ahead and just do this as your first thing. So this is our prior knowledge activator. So I want you to go ahead and use your inverse operations to solve each one-step equation below. So I want you to go ahead and pause this, work out these 3 problems, and then go ahead and unpause it. All right, so right now I'm going to assume that we've already paused it and unpaused it to work these 3 out. So I'm going to go ahead and work through them so you can check your answers. So first, it told us to use our inverse operations. So I just want to refresh your memory. We know that multiplication and division are inverse operation set. So in order to get rid of multiplication, we divide. In order to get rid of division, we multiply. Same goes with addition and subtraction. So in order to get rid of addition, we subtract, and in order to get rid of subtraction, we add. So let's use that and go ahead and solve each one-step equation. So in the first one, we can recall that a number next to a variable implies those 2 numbers are being multiplied. And we just I just said that multiplication and division are each other's inverses. So to get rid of that in order to get rid of that multiplication, we're going to go ahead and divide. So 4 divided by 4 is 1. So we have 1x, but what I do to that one side, we know we have to also do to both sides. So 16 divided by 4 is going to give me 4. And 1x equals 4, or we can just simplify it to x equals 4, because we know right here that the 1 in front of that x is assumed. So we know x has a value of 4 because when there's no number there, it's an assumed 1. All right, so for 2, I have addition. We said that the inverse of addition was subtraction. So to get rid of plus 9, we're going to subtract 9. And again, what I do to one side, I have to do to both sides to keep this equation balanced. 9 minus 9 is 0. So we have x is equal to 13 minus 9 is 4. All right, and then our last one, we have x minus 8 equals 14. We know our inverse of subtraction is addition, so we're going to add 8. Minus 8 plus 8 cancel to 0. And then we have x is equal to 14 plus 8. Because of what I do to one side, I have to do to both. And 14 plus 8 is going to give me 22. All right, so this is going to be super helpful because we're talking about our one-step inequalities. And actually, inequalities can be solved just like an equation, but with a few exceptions. So if you could do those last 3 problems, I know you are going to nail today's lesson. All right, so the goal when solving an inequality is to isolate the variable. Same goal as an equation. So you're going to go ahead and isolate the variable by using the inverse or opposite operations, which have not changed. The inequality must remain balanced. So like before with the equations, what we did to one side, we're going to have to do to both sides in our inequalities. And then when you multiply or divide by a negative number, the inequality sign is flipped. And that will make sense in just a minute when we get to some problems that look like that. So if you're still writing, go ahead and pause this because I'm going to move on to the next slide, and then you can unpause it when you're done. All right, so I am going to show you how to do these first 2 problems. So we need to solve an inequality. I'm going to go ahead and do the same thing I would do if this said n plus 5 equals 16. So I'm going to do the same thing I would do with an equation. So I know my inverse pairs, and I'm just going to put them up here for my reference again, are addition and subtraction. So those are used to get rid of each other. and multiplication and division. All right, so on this first one, I have addition. So we know the inverse of addition is subtraction. So to get rid of plus 5, we're going to subtract 5. And we know that we even still with our inequalities, we need to keep them balanced. So what I do to one side, I have to do to both. So I'm going to subtract 5 on the right as well. This cancels because 5 minus 5 is 0. So we are left with n. And like an equation, when we bring down our equal sign, we're just going to bring the inequality down exactly how it is. And then 16 minus 5 is 11. So what we have is n is less than or equal to 11. So let's pick a number less than 11 to check it. Let's say n is 10. Is 10 less than 11? Yeah. So we're going to go ahead and say n plus 5 equal to or less than 16. We chose 10 to be our n, so 10 plus 5 is less than or equal to 16 is 15 less than or equal to 16. Is that a true statement? Yes. So we did it right. Now let's go ahead and solve it real quick. We talked about 2 types of circles yesterday when we are graphing these inequalities. I want you to tell me this to yourself, obviously, because I cannot hear you through your screens. We'll talk about it more in our guide to practice. We had 2 types of circle. We had a closed circle and an open circle. Which one meant we included that number? And when we include that number, it is like in one where it said less than or equal to. So if it's or equal to, which one includes that number? Is it an open circle or a closed circle? That's right. A closed circle can be less than or equal to or greater than or equal to. How about an open circle? What do we have left? That it does not include it. So less than or greater than, but not equal to. All right. So let's go ahead and graph it. So we have n is less than or equal to 11. So we have or equal to. So we know that we're going to have to do a closed circle. And I like to go ahead and put mine in the middle. So then I'm going to graph all my numbers bigger than it because we know this is a regular number line and then smaller than it. And then we want to graph all the numbers less than or equal to 11. Are the numbers to the right less than 11? Is 12 less than 11? No, so my test point didn't work. Is 10? Did we check 10? We already checked 10. Is 10 less than 11? Yes. So we're going to go ahead and shade that direction. And I have an extra bonus check for you. Yesterday, when we were talking about this, I told you a little trick. And I said this trick only works if your variable comes first. And in this case, it does. We have n is less than or equal to negative, or not negative, just 11. I said if your variable comes first, we can look at which direction that inequality is pointing, and that's the direction you would shade. Well, n comes first, and it's pointing left, and that's which direction we shaded, so we know we did it right. All right, so let's go ahead, and we're going to look at number 2. We're going to go ahead and solve it again like we would a regular equation. So we know to get rid of subtraction, we're going to go ahead and we're going to use addition. So minus 8, we're going to add 8. But what I do to one side, I have to do it to both to keep them balanced. Minus 8 plus 8 is going to cancel. We know that. So we're going to have C, bring down our greater than sign. And 14 plus 8 is 22. So then we have C as greater than 22. So now we can go ahead and check it. When we check it, we want to check a number that is greater than the 22 because it says C is greater than 22. So let's pick a value bigger than 22. Let's say 23. So we have 23. So let's say we have C minus 8 is less than 14. And we're going to say C is 23. So let's go ahead and plug it in. 23 minus 8 needs to be greater than 14 for us to know that we did this right. So again, let's check it. So 23 minus 8 is going to give me 15. And is 15 greater than 14? It is. So we know that we did this right. All right, so we're going to go ahead and graph it again. This time we are not including the numbers. So does it need to be a closed circle or an open circle? That's right, an open circle. All right, so we're going to put our 22 right there in the middle. We're going to put some numbers bigger than it and some numbers smaller than it. All right, so we want all of the numbers bigger than 22. And we already went ahead and checked 23. So we're going to shade towards that 23 and keep going. And again, like I said, with our trick, our variable came first, so we can see that the arrow pointed to the right, and so did our shading. So we did that right. Awesome. So what I want you to go ahead and do is pause this now. I want you to solve 3 and 4. Ignore this bottom part until we go through it as a class. Just solve 3 and 4, check it and graph it. Pause this and then unpause it, and we'll go through it together, and then we'll handle that bottom part. Just solve 3 and 4, check it and graph it. All right, so by now I'm assuming you've already paused this, you worked through the solving, the checking, and the graphing, and you're ready to go ahead and check your answers. So we know we have multiplication, and what's our inverse of multiplication? Division. So we're going to go ahead and divide both sides by 12. 12 divided by 12 is 1, so 1g. We're going to bring down our less than sign. 48 divided by 12 is 4. And we can simplify that to g is less than 4. Because we know when there's no number shown, it's assumed that 1. So let's go ahead and check that. You needed to have picked a number less than 4. I'm going to pick the one right before it, so I'm going to say 3. So let's say g is 3. 12 times 3 needs to be less than 48 for this to be true. Well, what is 12 times 3? It is 36. Is 36 less than 48? It is, so we've done it right. So then, when you graph this, did you use an open or a closed circle? Why? That's right. We should have chosen an open circle because it does not include the 4. We're going to put our 4 here. We're going to put some numbers bigger than it and some numbers smaller than it. We already said that 3 makes this true, so we know we're going to go ahead and shade towards it. And we know that 2 and 3 and anything smaller than them are going to be smaller than 4. And again, a variable came first. So we can check and see that that inequality symbol points to the left, and so does our shading. Awesome. So on 4, we have division. We know that that line there, we learned that that line there implies division, and so P is being divided by 3. We know to get rid of division, we use its inverse, which is, you used, right, multiplication. So in order to get rid of P divide 3 less than 9, in order to get rid of division, we're going to use multiplication. So we can say 3 over 3P is greater than, then 9 times that 3. 3 divided by 3, P is just 1. So, before I'm jumping the gun, 9 times 3, because what we do to one side, we have to do both sides to keep it balanced. 9 times 3 is 27. And then we can simplify it. We know 3 over 3, 3/3 is 1 whole P. And 1P is greater than 27, and you can drop the 1. So we know P is greater than 27. So let's go ahead and pick a number bigger than 27. How about 30? So we have 30 divided by 3 should be greater than 9 because P is 30 in this case. So we replace P with 30. So 30 divided by 3 should be greater than 9 for us to have done it right. Well, 30 divided by 3 is 10. Is 10 greater than 9? Yes. So we did it right. All right. So we can go ahead and plot it. Are we going to do an open or a closed circle? An open circle. Why an open circle? Because it does not include that 27. Awesome. We're going to put our 27 here. We can say 28 and 29. 27 comes 26 and 25. We already tested 30. We know 30 comes right here. So we're going to go ahead and shade towards that 30 we tested. So all of those numbers are bigger. So we know the further right we get are bigger. So we know that those numbers are bigger than 27. And again, our variable comes first. So we can see that the inequality point's right. And so did our shading. So we did it right. All right, I want you to go ahead and fill in these observations that you made about the problems above. This is one of the things I'm going to be looking for when checking your notes from today. I want you to think about what we talked about just now in these first 4 and tell me your observations that you can make about the problems above. And I'm pausing, but you might want to pause because I'm going to move on in a second. I was just stopping so you get a chance. Pause this if you're still working, thinking about that. And then I have a couple more for you. All right. So I said in the beginning that inequalities sometimes may involve negative numbers. So remember, I told you that if we multiply or divide by a negative number, be sure to flip the sign. So let me show you what that means. So on 5 here, we have negative 4k is less than or equal to 22. We know in order to get rid of multiplication, we're going to divide. So we are dividing both sides by a negative 4. So this is what I was talking about right here. We are dividing both sides by a negative 4. All right. So negative 4 divided by negative 4 is 1. So 1k. 22 divided by 4. Well, let's see. 4 into 22. 4 goes into 22 5 times, which is 20. With 2 left over, we're going to go ahead and add a decimal and bring down a 0. 4 goes into 20 again 5 times. And 20 minus 20 is 0, so we're done. So I know 1k, and our answer is 5.5. And I intentionally have not put my inequality symbol yet. And we know a positive divided by a negative is a negative 5.5. And we have one last thing. We said that we must flip the sign. So because we divided both sides by a negative 4, that sign goes from less than or equal to greater than or equal to. You flip which direction that is pointing. And I want to point out, you are flipping the direction of that sign. Never once will that change that or equal to. So here you're including the answer. So it's greater than or equal to. If it was just greater than or less than, but it doesn't include the or equal to, that does not change. That never changes. The greater than becomes less than and vice versa. So both of them greater than or equal to becomes less than or equal to. Greater than becomes less than, and less than becomes greater than. Never do you switch between these. That bottom or equal to, if you have it, it stays. If you don't have it, it stays away. But so you flip the sign, but never change the or equal to or not or equal to part. All right, so then we can go ahead and simplify that to k is greater than or equal to 5.5. So I want to do something real quick. So hold on to where we are. I just want to show you something. We'll check it in just a second. I want to sidetrack for a second. So we had this. What I want to show you, because this is actually one of the big issues I see when I teach this. Let's say instead of this, and I really actually want to copy the whole thing. This is what we got when that 4 was negative, right? So copy. We're going to delete that. I'm going to paste this here. And we're going to make it smaller so that we can see it as we're seeing what we may do wrong. So let me show you something. Let's say instead of that, we have 4k is less than or equal to 22, but negative. We would still, to get rid of multiplication, divide both sides by 4. 4 divided by 4 is 1, so 1k. All right. And again, let me leave out my sign until the end. So sign here. The division doesn't change. 22 divided by 4 is 5.5. We still just have one negative and one positive, so it's negative 5.5. The biggest mistake I see with this is that because this is negative, you want to flip the sign. You do not flip the sign unless, you might star this, only flip sign if number, so I'm just going to write number, being multiplied or divided on both sides is negative. So what that means is this 4 here being divided on both sides is negative. That flips the sign. This 4 here being divided both sides is positive. It did not matter that that 22 was negative. That sign is going to stay the same. And I know this extra problem was not on the guided notes if you're following the guided notes, but it might be important to see that counterexample because that is one of the biggest issues I see. So you want to go ahead and pause this and fill in that counterexample? You can. But now I'm going to jump back to check it. I just, before I forgot, that's one of the big issues. I want to show you the thinking of sometimes I see that go wrong. All right, so let's check and make sure we did it right. So to see that when we flipped it, we're still going to get the right answer. We said that k had to be a number bigger than 5.5. It had to be a negative because we had a positive and a negative. H didn't transfer it. All right. So let's check it. What's a number bigger than negative 5.5? And remember, our negative numbers, the higher the number, the higher the negative. So like negative 7, smaller than negative 5.5. Well, we know that positive numbers are all greater than negative numbers. Let's plug in a positive number. So let's say 2. So we have 2 is k. So negative 4 times the 2 we're plugging in for k needs to be less than or equal to 22. All right, so 4 times 2 is going to give me 8. A positive and a negative is going to give me a negative. And equal, less than or equal to 22. Is negative 8 less than or equal to 22? It is. So we're going to go ahead and graph that. So I have 5.5. Let's put that where it needs to be. I have, let's say, 5.5. So negative 3. I'm going to do this. Negative 3. We know the further left, the higher those numbers are going to look. Because the higher the actual number with negatives, the smaller it gets. So we know that negative 5.5 is going to fall between negative 5 and negative 6. Do I need to put an open or a closed circle to include negative 5.5? A closed circle. All right, and we're gonna say that's about halfway. It may not be exact, but we're gonna eyeball it. All right, so and then we tested a positive number. Which direction are my positive numbers? To the left or to the right? To the right. Because the further right we go, the higher those numbers are going to go. And we said K was greater than 5.5. All those numbers to the right are greater. All right. And then our variable came first. So we can use Mrs. H's cool trick. It points to the right. Is that what direction we shaded? Yes, it is. And there was our example. All right, so we're going to go ahead and pause this now. And you're going to work through this one. Remember, there is a negative in that negative 2 being the S is being divided by. I want you to go ahead and try this one. Solve it, check it, and graph it. And when you're done doing so, unpause this because I'm going to give you a second to be able to pause it, and I'm going to go over it. All right, so by now you should have already worked through it, paused it, worked through it, and now I'm going to go through it so you can check it yourself. All right? So on 6, we have S is being divided by negative 2. We know to get rid of division, we need to multiply. I know, I'm probably sidetracking you. I was going to blur out the 6. I'll just rewrite it. Okay, so in order to get rid of division, we need to multiply. So we have S divided negative 2 is greater than 5. So to get rid of divide by negative 2, we're going to multiply both sides by negative 2. So negative 2 over negative 2. S is greater. It's not greater. We divided by negative 2 is less than 5 times negative 2 is negative 10. 2 divided by 2 is 1, a negative and a negative is a positive, so we have 1s with our flipped less than 1, and see how we flipped it and did not add an or equal to sign? Negative 10. And we can go ahead and check that original equation, and it should show us that flipping was right. So let's go ahead and what is a number less than negative 10? If I'm $10 in debt, I want to be more in the hole. Let's say I'm $15 in debt. So we have, well, let's say $16. S divide negative 2 is greater than 5. Let's say S is negative 16. So negative 16 divided by negative 2 needs to be greater than 5 for this to be true. Well, 16 divided by 2 is 8. A negative and a negative is going to be a positive 8 and greater than 5. Is 8 greater than 5? It sure is. All right, so what I want you to do, not what I want you to do, what I'm going to do is go ahead and graph this real quick. So we're going to put our middle at negative 10, smaller negative 11, negative 12, negative 9, negative 8, because our negatives work backwards. The smaller the number, the bigger the negative is. All right, so we already said that negative 16 made this true. And we have no or equal to, so did we do an open circle? Well, it is an open circle. Did you do an open circle? Why? Because it doesn't or also equal negative 10. It can't equal negative 10. We checked negative 16. So we know that all those numbers less than negative 10 are going to make it true. And again, S comes first. That inequality is pointed to the left. So we know that we did it right. All right. So we're going to go ahead now and I'm going to solve these 3 problems. So let's look. We have multiplication. We know to get rid of multiplication, we're going to divide. So we're going to divide both sides by negative 7. Negative 7 divided by negative 7 is just 1. So 1x. We divided by negative 7. Star. So we're going to flip our inequality. 35 divided by 7 is 5. A positive divided by a negative is a negative. So x is less than or equal to negative 5. So we're going to plot our negative 5. It's or equal to. So we're going to do a closed circle. And we are going to go ahead and put our negative 5 here. Further left, those we're going to get farther in debt. And lower in debt because these numbers are bigger. All right, you're less than the whole. All right, so which direction would we need to shade if we want all the numbers less than negative 5? Well, the higher the number, the further in debt we are, so we're going to shade to the right. We know that negative 6 is less than or equal to negative 5, so we did that right. And we have a closed circle because it's or equal to, so we're looking good. And our variable is first, pointing to the left, so we need to know we did it right. And if we wanted to go back and check it, we could plug in negative 6 because that's one of the ones we have shaded. Negative 6 times negative 7. Well, 6 times 7 is 42. A negative times a negative is a positive. So negative 7 times negative 6, that's our check, equals 42. And 42 is greater than or equal to 35. Awesome. Divide. All right. So let's go ahead and do 8 and 9. So to get rid of subtraction, we add. So minus 16 plus 16 cancel. So we have x is less than 11 plus 16 is 27. All right, we're going to put our 27 in the middle. 28, 29, 26, 25. We want all the numbers smaller than 27. Is 28 smaller than 27? No. Is 26 smaller than 27? Yes. So we're going to shade to the left, and I didn't circle it, so I'm going to go back and ask us. It's not or equal to, so I need to open our closed circle. That's right, open circle. Awesome. So now let's look at 9. We have addition. To get rid of addition, we're going to use subtraction. So we're going to go ahead and subtract 10. 10 minus 10 is 0. So x is less than or equal to 8 minus 10. I can't take 10 from 8. So I'm going to say keep the 8, change subtraction to addition, make that 10 a negative. Now, our rule for adding one positive and one negative is to subtract and keep the sign of the number with a larger absolute value. So 10 minus 8 is 2. 10 is farther away from 0 than 8, or negative 10 is. So we're going to keep the sign of the negative 2. All right. And this time, I'm going to go ahead. We're going to put our x first. See here how the point is closer. So when I flip it, it's going to be completely flipped. And this is just so that I can see it with my x first. So we have negative 2. We know that negative 2 is bigger than x. So let's ignore me rewriting it first. And then I'll flip it so I can check. So we have negative 2 is greater than or equal to x. So negative 2 is bigger. So what that tells me is that x needs to be smaller than negative 2. So we know all of our numbers smaller than negative 2 go this direction. We know that it can be negative 2, so we're going to fill it in. And if I wanted to, that's what I was trying to say, we can go ahead and flip everything. And now that my variables first are inequality is pointing left, and we've done it right. And I should have filled in negative 3, negative 4, negative 1, 0. All right, so here is your check to make sure, wrong direction, to make sure you've got everything. I want you to pause this. I want you to solve and graph 10, 11, and 12. Summarize what you've learned. And when you unpause it, if you got these right, and you feel comfortable with this, I'm going to tell you you can go and do your Schoology work. If you don't get it right, I'm going to tell you probably aren't as comfortable with this. Please come to guided practice. Either way, you are welcome to your guided practice. But if you don't get these right, you should come to guided practice before automatically jumping into this Schoology work. All right. So, pause this, solve it, and graph it. And then put your summary, because that's the other key thing I'm going to be looking for today. And I'm going to pay attention. After I go through it, if yours is wrong, don't just change it. Do it underneath, because I really would like to be able to gauge whether or not you did it right or wrong. All right, so you should have already paused it and worked through them, so let's go ahead and check it. We have x divided by 8. How do I get rid of division? Multiplication. So I have x divided by 8. So we're going to go ahead and multiply both sides by 8. And we have 8 over 8x is greater than negative 3 times 8, negative 24. So 1x is greater than negative 24. All right, so it is not including negative 24, so we're going to do an open circle. Negative 24, negative 25, negative 26, negative 23, negative 22. And then we want all the numbers bigger than it. We know on a regular number 9, as we go further right, it gets bigger. Our variable was first, and it points to the right. So we did it right. We know in order to get rid of multiplication on this next one, we use division. So you're going to divide both sides by 6. All right. And we're going to say that x, because that's 1x, is greater than or equal to negative 18. And it didn't flip because this top number is negative. Stay the same. So we're going to go ahead, shade in our 18 because it's being included, our negative 18. And we have negative 17, negative 16, negative 19, negative 20. We want all the numbers bigger, so we're going to shade to the right. And our variable came first, and it pointed to the right. And the inequality pointed to the right. So we did it right. And I have addition. So we use subtraction. 7 minus 7, x is greater than or equal to plus a negative. And two negatives together make a bigger negative. So 22 is going to be smaller than what x is. So it includes 22 though. 22 is either equal to or smaller than. So if 22 is smaller than what it is, I need everything bigger than it. So we're going to go ahead and shade right. If we wanted to flip it, x is greater than or equal to negative 22. With our variable first, points to the right, we did it right. All right, and as I said that, what I realized is I want one more problem for you to do to truly be able for you to tell me you know how to do this, because there's one key thing in this that is different than equations that weren't in my gauging of what you know. I want you to additionally solve this. Now pause this and solve it. Why did I put an equal sign? That's what I get for coming up with them off my head. If you know what to do with this, you got all those three right, awesome. But make sure you can do this correctly as well and graph it before you decide you know what you're doing and you can jump ahead on your schoolwork. So pause this. Awesome. All right. So I think that we all, with those first three, know if you got them right, know that you know your shading, your open circles and your closed circles, because we talked about that yesterday. You know that solving them is the same as the one-step equations. The one thing that wasn't included, and I wanted to make sure when you were ensuring that you have mastered our objective, was that the key difference between equations and inequalities is that when we multiply or divide by a negative, that sign is flipped. So I wanted to make sure before I was like, yes, if you get these right, you feel free to go ahead and do it if I didn't cover every single thing. So to get rid of division, we need to multiply. So negative 6. So times negative 6. This cancels because I have negative 6 over negative 6, which is just 1. So negative 6 over negative 6x. We'll go ahead and do it like that first and then say that it's 1. So negative 6 over negative 6x, sign flips, less than or equal to 3 times negative 6 is negative 18. And like I said, that cancels to 1, less than or equal to negative 18, because 3 times 6 is 18, and a positive and a negative is a negative. And then when you graphed it, you have negative 18, negative 19, negative 17, negative 16. It's or equal to, so we have a closed circle, and we want that x is all the numbers smaller. And because x came first, we know we shaded the right direction. All right, so if you got those 4 problems right, make sure you summarize that lesson and you feel very comfortable with this, go ahead and do the Schoology work. All right, perfect. Let's talk about what we learned today. Our objective was that we can solve and graph one-step equalities. You rocked those last 4 that I had there. Kind of Hail Mary that number 4 to make sure we covered every single idea that entails with one-step equations or inequalities. So solving one-step equalities is exactly the same as one-step equations. The only difference is that if we multiply or divide by a negative, the inequality sign flips. Graphing them is exactly the same as we talked about yesterday. So an open circle does not include the number, a closed circle does. All right? So, like I said with those 4 problems, if you got all 4 of those problems right, and you included a good summary, and I really just did that for you, talk about what we learned, explain the objective. Don't just say that we learned to solve and graph one-step equalities. Explain how to do that in your summary, because that's one of the key things I'll be looking for. I really hope that those last 4 that you left them the way you solved them so I can see whether or not you knew what you were talking about. Either way, if you got those 4 right but you still want some more practice, please come to guided practice. If you didn't get those 4 right, please come to guided practice and please come with questions if you don't know why you got them wrong. So our guided practice will be today. If you have any other questions, let me know. Remember, my office hours are posted in our important resources folder on the Schoology page. Otherwise, I'll see you in guided practice. After that, if you haven't already, make sure you do our Schoology work. If you're not comfortable, don't do it before guided practice. All right, guys, that's it. Have a great day. Bye.